Lesson 311, the Triangle Sum Theorem, Part 2. The objectives in this lesson is to use the Triangle Sum Theorem to to solve problems, and to use the exterior angle theorem to solve problems. Two terms that we're going to be talking about in this lesson, are exterior angle of a polygon, and that's an angle formed by two sides of a polygon, one of which extends outside the polygon, and each interior angle of the polygon forms a linear pair with the exterior angle. That'll going to make a lot more sense when we get there. And then remote interior angle, an angle inside a triangle that is not adjacent to a given exterior angle. Here we go. Angle BCD is an exterior angle of triangle ABC. So here's C, okay? That's an exterior angle, BCD. Oh goodness, I just jumped right on that. Okay, and then angle A and angle B are going to be your remote interior angles. Just think, if you're working with the remote control for the TV, you're sitting far away from the TV, so that's why they call it a remote, because you're far away from the TV. Well, that's the same with these interior angles. They're far away from the exterior angle, so they're going to be called remote interior angles. Now, the exterior angle theorem says, and you can read it up there, but basically what it's saying is that the measure of angle 2 plus the measure of angle 1 plus the measure of angle 2 is going to equal the measure of angle BCD. That's all it's saying. And it will work that way no matter which exterior angle you're using. You always use its remote interior angles to use this theorem. And you'll see some examples of that when we're doing the lesson. And again, do not assume that anything is drawn to scale. Only use information that's explicitly given or marked. So this says, oh, let me get my pen ready. Ink color blue so it'll show up everywhere. It says, identify the exterior angles of the angle given. So if I'm going to look for the exterior angles of angle 1, let me get my pen going here. Here's angle 1. Angle 1's exterior angles are going to be 7 and 8. Alright? There, it just shows you how it's correct. Oh, let me go back because I'll be giving y'all the correct answers first. Let me go back. Oh, not that far. There we go. Okay, exterior angles for angle 2 are going to be 4 and 9. The exterior angles for 3 are going to be 5 and 6. Now you can see that. There's 7 and 8. There's 4 and 9 for angle 2. And there's 5 and 6 for angle 3. Okay, now let's do some math. Find the measure of the exterior angle for the given measures of the remote interior angles. It says find the measure of angle 6 if the measure of angle 1 is 95 degrees and the measure of angle 2 is 32 degrees. Now you got to remember that exterior angle theorem. We know that the measure of angle 1 plus the measure of angle 2 equals the measure of angle 6. So angle 1 is going to be 95 degrees. Angle 2 is 32 degrees. I add those guys up. Well, let's do it the real algebra way. Okay, now I add those guys up. 95 plus 32 is going to be 127. And that equals the measure of angle 6. Okay, now I'm going to take my eraser because I don't want all my numbers getting confused here. I'm going to erase those guys and to do part B. For this one, I'm going to change my ink color. So for B, it says find the measure of angle 4. Oh, you can't see it with yellow. If the measure of angle 2 is 46, let me find me another color that'll show up. Here we go. This is 46, and measure of angle 3 is 29. Okay, now let me tell you something else about the remote interior angles. They will never be adjacent to the exterior angle we're looking for. So there's no way that I can, well, there is a way I can figure out the measure of angle 4 if I know 1, but that's not what we're doing in this lesson. Okay? So what I have to do is remember what that external angle theorem says. It says, okay, I can take the measure of angle 2, let me write that correctly, plus the measure of angle 3 is going to equal the measure of angle 4. Well, angle 2 is 46, angle 3 is 29, and I add those two together, 49, no. Let's do this correctly. 46 plus 29 equals 75. There you go. And that's all you got to write out here. Measure of angle 4 is 75 degrees. Okay, let me erase that so it doesn't get confusing when I'm looking for my next problem. Okay. Let me find a color that's going to show up on white and black. Oh, purple won't show up on black. Let's use this green here. It'll show up. It says the measure of angle 5, if 1, I've lost my pointer, 1 is 103 degrees and angle 3 is 17 degrees. They want to know angle 5. So I got the measure of angle 1 plus the measure of angle 3 equals the measure of angle 5. Notice how 1 and 3 are the remote interior angles. So I've got 103 plus 17 equals the measure of angle 5. So I'm betting that's going to be 120. Yep. So I've got 120 equals the measure angle 5. And I can come up here and write that. There we go. That's all you've got to do to solve those problems. Okay? Just remember that your interior angles are remotely. They're far away from the exterior angle you're looking for. And there's the correct answers. Yay, Miss Poor did it. Okay, this one says find the measure angle X, measure angle Y, and the measure angle Z. And they gave us these two measures down here at the bottom. And you're going, okay, what are we going to do with this? Well, since we're working with the exterior angle theorem, we're going to look for Y first. Okay? And let me write that up here. We're going to say the measure of angle Y will equal 42 plus 55. You see, because Y, angle Y, exterior, and 42 and 55 are your remote interior angles. That's why I chose that. So 42 and 55 will give me 7. That was 2 and 5 and then 9. So the measure of angle Y is going to be 97 degrees. Now I can figure out the measure of angle X by adding 26 and 97 together because of the triangle sum theorem. I'm going to put measure of angle X equals measure of angle Y plus 26, and I'm going to put out here, I'm going to draw a triangle. Triangle Sum Theorem. That's how I abbreviate theorem. So I'm going to have the measure of angle X equals 97 plus 26. So let me figure 97 plus 26. And I kind of wrote that out backwards. That's not true. I should put a plus sign right here. Let me do that. I kind of messed that up. So now I have 180 minus 123. Thank goodness I got the answers on the next slide. I'm getting the correct answers, I just kind of did that really confusing. Alright, and now angle Z, we could use the the exterior angle theorem, but look right here, Y and Z are a linear pair, so the measure of angle Y plus the measure of angle Z has to equal 180 degrees. So I got 97, so I take 180 minus 97 is going to give me 83. So angle Z is 83 degrees. Now let's see if I got it right, because 83 plus 42 plus 55 better add up to be 180. 83, 42, 55, hot diggity dog diggity, it worked. There we go. So when you're solving them like this, you're just solving a big old puzzle. And there we go. 57, 97, 83. It all worked out. Oh, goodness gracious. What does this one say? Measure of ACD equals 106. Measure of ABD is 64. Find these other ones. Well, let's mark this up. ACD would be this little guy right here. He's 106. ABD would be this guy down here, and he's 64. They want us to find BDC. Well, look right here. These two angles right here, let me write this out. The measure of angle ACD plus the measure of angle BCD equal 180. So I got 106 plus X, and you know what? If you'll notice, I'm answering part B first. You answer them in whatever order is easier for you. This was just, I always go, when I'm solving, to me these are big puzzles, and I solve whichever part of the puzzle looks easiest first. So 74 degrees. And what's crazy, they probably wanted me to use external angle theorem or something. I probably messed it up. BDC, these three guys right here in the triangle BCD, they're going to add up to 180. That's your triangle sum theorem. So I've got angle BCD plus the measure of angle CBD plus the measure of BDC is going to equal 180 degrees. I just found out that BCD, is 74 degrees. That's a 4. CBD is 64 degrees. That was given to me. I'm going to add those two guys up. I think I get 138, because 4 and 4 is 8. 7 and 6 is 138. Now 180 minus 138 is 42. there you go. That's how we figure that out. Let's see how they figured it out in the key, because I have a feeling they did not do it that way. Oh, look, they didn't. It says ACD is the exterior angle for remote interior angles B and BDC. So they're saying that this right here is 1 over 106. Okay, see how that works? They plug that in for ACD, they plug the 64 in for the angle they knew, and then they solved for BDC, and they got 42. I don't think I got 42 on mine, so that shows I did it wrong. No, I got 74. I think that's because maybe well, no, because even if I assumed, it's still correct. 180 minus, I don't know why that was ended up being wrong. Because all I did was figure they were a linear pair. I guess they're not. See, there I went, assuming. That's what happens when you assume that the line, that it was a straight line and they added up to 180. So you get to see how it can be done wrong. Okay, this one says that BDC comes out to be 74. Ah, you know what? I just switched them. This one, I said this one was 42 and this one was 74. They said BDC was 74. They just switched them. I don't know if I totally agree. I don't agree with their math. It still adds up to 180 though. Okay, what we learned is an exterior angle of a triangle is an angle formed by a side of the triangle and by extending another side. A remote interior angle is one of two angles inside the triangle that are non-adjacent to the given exterior, and the exterior angle theorem states that the measure of an exterior angle of a triangle is equal to the sum of the measures of their two remote interior angles. So, of course, you need to read through the LMS and complete the student guide for lesson 311. Read through the pages in the reference guide. Complete these problems in the problem set. Don't ignore that part just because you don't like it. And please come to Toga or contact me if you have any questions before you take the quiz. And that's going to be it for lesson 311, and thanks for listening.